Welcome back, everybody, to another deep dive. And today, we're really getting into something, something that's sort of all around us all the time, but maybe we don't always think about it. It's vibration. So we're diving deep today with this book that explores vibration, and you know, I think when people think of vibration, they often think of, you know, like a phone buzzing in their pocket or something like that. But this book gets at how vibration shapes the world around us.
Yeah.
Like in much bigger and more fundamental ways.
Yeah, it really is everywhere, shaping all those patterns and structures we see, from like the smallest atom to the largest galaxy.
Okay, so, maybe when I think of galaxies,
Yeah,
you know,
right.
maybe vibrations isn't the first thing that pops to mind. So help me connect those dots.
Well, a good place to start is with this concept of periodicity, which is something, you're experiencing right now, even as we speak, like the beating of your heart
Mhm.
or your breath, and inhale, exhale, or even the ocean tides. These natural rhythms and cycles, they're part of the essence of life and nature.
So periodicity is all about those repetitions and patterns, right? I can see that in, the examples you gave, but how does that apply to something as huge as a galaxy?
Well, think about the structure of things, like how atoms are arranged in a crystal or the segments of a worm's body, those repeating patterns. But the book takes it even further. It talks about like the organization of meson clouds in nuclear physics and plasma oscillations, in solar physics. Even in the vastness of space, periodicity is there.
Wow, it's kind of mind-blowing to think that periodicity is embedded in the universe at those scales, from
Yeah.
tiny particles all the way up to,
Yeah.
huge systems. But a lot of this is invisible, right? Like how do we actually see these vibrations in action?
That's where the book's experiments come in. They use sound to help us visualize these vibrations. Like a really classic example is using a metal plate. You attach it to an oscillator and then sprinkle some sand on it.
Okay, so I'm picturing this metal plate,
Mhm.
vibrating like crazy and the sand just bouncing all over the place.
It's not random chaos, actually. The sand arranges itself into these really intricate geometric patterns. They're called Chladni figures.
Wait, so the sound is making the sand form those shapes. How does that even work?
It's similar to how your eardrum vibrates when you hear a sound. So the plate vibrates and the sand moves to the areas where the vibration is least intense.
Oh, so it's like the sand is showing us the architecture of the sound waves, but
Gotcha.
but it's not just sand and metal, right? Like,
Right.
are there other ways to see these patterns?
Yeah, we can see these effects in lots of different materials. And it gets especially interesting with liquids.
Liquids. So instead of like those static patterns, we'd see the shapes moving and flowing.
Exactly. So imagine vibrating a pool of liquid. You might see swirling vortices, pulsating wave fields, even like delicate lattice-like structures, they almost resemble fabrics.
Wow, that's some pretty crazy imagery. It's like watching the liquid dance to the vibrations.
Yeah, it really is like a dance. And those liquid formations, they're not just pretty to look at. They also show us those dynamic forces within the liquid itself, all that movement and flow.
So we've seen how sound can make sense, make patterns, and make liquids flow in these cool ways. But are there any examples in the book where these vibrations actually change how matter behaves?
Oh, definitely. Like one example is how vibrating liquids can seem to defy gravity. If you vibrate a liquid on a tilted surface, it can actually cling to that surface. Like it won't slide down as long as the sound's going.
That's wild. It's like the sound's creating this invisible force field.
Yeah.
So much for gravity. But I have to ask, with all these different phenomena, is there some sort of unifying principle at play here?
Yeah. The book talks about the basic triadic phenomenon of vibration, which basically means every vibrational effect has three parts: form, movement,
Hmm?
and periodicity.
Okay, break that down for me. What does it mean that every vibration has those three elements?
So form is like all those visible patterns and textures, like those Chladni figures we talked about, or the wave lattices in liquids. Then there's movement, which is, all that dynamic flow, the pulsations, the rotations.
And then periodicity is like that underlying rhythm, kind of like the conductor of the vibrational orchestra.
I like that analogy. And the point is, these three things are always connected. They're constantly shaping each other.
So you can't just think about the shapes or the movement or the rhythm on their own. It's the combination that makes these effects so interesting. But we've been talking about small-scale stuff. Does this triadic phenomenon apply to bigger systems too?
Oh, absolutely. I mean, we've talked about atoms and liquids, but this concept applies to everything, from tiny cells to huge planetary systems.
So this seemingly simple concept has implications for the whole universe. That's incredible. But if vibration is behind all these things, does that mean everything's vibrating all the time, even if we can't see it or hear it?
That's a great question. And it brings us to a deeper understanding of periodicity, because it doesn't always show up as sound vibrations. There are other forms of rhythm and repetition in the world, even without audible sound.
Really? Give me an example. I'm having trouble picturing periodicity without sound.
One of the coolest examples is something called Lees-Gang rings. So picture a chemical reaction happening, but instead of just a uniform mix, you see these concentric patterns, like rings on a tree trunk.
Okay, so a visual pattern, but no sound.
Right. The rhythm in Lees-Gang rings, it comes from the periodicity of the chemical process itself.
So it's like a silent chemical symphony. It makes me wonder what other hidden rhythms are out there, beyond what we can hear.
That's the exciting part, and there are plenty more examples where that came from.
Well, I'm definitely ready to keep exploring. I can't wait to see what else this world of vibration has in store for us.
Me too. Yeah, it's amazing how much we can learn about vibration by just like observing these phenomena,
Right.
without trying to, put them into boxes or anything.
Yeah, it's like we're learning a new language, like the
Mm.
language of vibration. And the more we understand it, the more we can pick up on those connections that we might have missed otherwise. So what other cool stuff has this book uncovered?
One experiment I thought was really neat uses a tonoscope.
A tonoscope. What's that?
It basically lets you see the vibrational patterns of the human voice.
So you talk into it, and it shows you the sound waves.
It's more than just like squiggly lines. The patterns are really intricate, and every vowel sound creates its own unique pattern based on its sound spectra and pitch.
Wow, that's amazing. It's like our voices are more than just sounds. They're vibrations too, carrying energy and information.
Yeah.
But I imagine like each person's voice would make a different pattern, right?
Exactly. So while the vowel A will always produce a certain kind of pattern, the specifics of that pattern would be different for everyone, almost like a vibrational fingerprint.
So you could use a tonoscope to analyze and compare voices.
Oh yeah, definitely. And the book even talks about using it to visualize the patterns of music. Like there's this example showing Bach's toccata and fugue.
I bet that's pretty trippy to see, watching the complexity of the music turn into these moving patterns.
Yeah.
But we've been talking a lot about sound-making visual patterns.
Yeah.
Are there any examples of vibrations like physically affecting materials?
Oh yeah, there are some really cool ones. One that comes to mind is the effect of vibration on lycopodium powder.
Like a podium powder. That sounds familiar.
It's that fine yellowish powder they use in a lot of science experiments and even magic tricks because it's so flammable.
Oh, right. I've seen videos of those like big fireballs they make with it. So what happens when you add vibration to the mix?
It's quite a show. When you sprinkle it on a vibrating diaphragm, it doesn't just go everywhere randomly. It forms all these tiny round shapes, and they all rotate and circulate within a larger pattern.
It's like a miniature solar system or something.
Yeah, kind of.
What happens if you change how strong the vibrations are?
Well, as the amplitude increases, the little shapes start to move towards the areas with the most intense vibration. They collide and merge. And eventually you get these huge eruptions and fountains of powder, forming these wild, swirling vortices.
Sounds like a crazy cosmic dance,
Yeah.
all driven by these unseen forces. But even with all that chaos,
Hmm.
there still seems to be some kind of order to it.
You're right. This is where the integrating effect of vibration comes in. So imagine all this lycopodium powder swirling around, and then the sound stops, and the powder just falls back onto the diaphragm
Uh-huh.
in a perfectly even layer like nothing even happened.
Wow, it's like hitting the reset button. So vibration isn't just about chaos, it's also about order and balance.
Exactly. It's that duality that makes it so fascinating. It can create and destroy, organize and disperse.
This is way more than I ever thought about with vibration. We've gone from simple sound waves to these incredible visuals, to like principles of order and chaos. It really makes you wonder what other secrets are hidden in this stuff.
Yeah, it's definitely a rabbit hole. But before we go too far down it, let's just take a moment to appreciate the range of effects we've seen.
You're right. I mean, we've talked about the creation of forms, the movement of particles, the pulsations, the rotations, even this integrating effect. It's like vibration is more than just a force. It's like a whole set of tools.
I like that. And what's really interesting is that these principles, they go beyond just sound. There's a whole category of periodic phenomena that happen without any sound vibrations at all.
Wait, really? Periodicity without sound. But I thought sound and vibration were like the same thing.
It might seem counterintuitive, but there are lots of processes in nature that have rhythm and repetition
Yes.
without any sound driving them, and that's what we'll be getting into next.
Periodicity without sound. Okay, I got to admit, that's a tough one for me to wrap my head around. I always thought of, sound waves, AS vibrations.
It's definitely a shift in perspective, but But once you start seeing it, you realize these silent rhythms are everywhere. Remember those Lees-Gang rings we talked about? You know, those concentric patterns in chemical reactions?
Yeah, yeah, those were amazing, like watching a chemical symphony.
Right. And the thing is, the rhythm there isn't from sound waves. It's from the periodicity of the chemical process itself.
Wow, so it's like a silent symphony. It
Yeah.
makes you wonder what other hidden rhythms are out there.
There are so many. Like the book also talks about this thing called dehiscence in doughy masses.
Dehiscence. What is that? Like something breaking apart.
Yeah, pretty much. It means splitting or bursting open.
Hmm.
But the thing is, when you pull apart a doughy mass, it doesn't just break randomly. The surfaces form these intricate patterns, like branches of a tree.
So the dough has this internal structure that guides how it breaks,
Hmm.
even though there's no sound involved.
Exactly. And the patterns are so detailed, it shows you the order and periodicity within the material itself.
It's amazing that even dough can have those hidden patterns. Driven by silent periodicity, I'm starting to realize I've been missing these rhythms all around me.
That's what's so cool about cymatics. It opens your eyes to those hidden connections in all of nature, the audible and the silent.
This deep dive has been incredible. We've explored so much, from the beating of our hearts to galaxies, sound waves, dancing liquids and powders, even the silent rhythms of chemistry.
It's amazing what we can learn from these simple phenomena. And it really shows us that we're just starting to understand how important vibration is in the universe.
It's pretty humbling
Yeah.
and exciting to think about, all the mysteries that are still out there. I definitely want to keep learning about this stuff. I don't think I can look at the world the same way again.
That's the power of new perspectives. And as you keep exploring, just remember to pay attention to those rhythms and vibrations all around you. You never know what you'll find.
I will definitely be paying more attention now. Who knew vibration could be so beautiful and complex and amazing? Thanks for taking us into this deep dive.
It was my pleasure. And to everyone listening, keep exploring on your own. Look for the patterns, listen to the rhythms, let the wonders of vibration open your eyes.
What if we could actually see all the vibrations around us? What kind of hidden patterns and rhythms would we discover? It's definitely something to think about. As we continue to explore the amazing world of vibration,